Hi guys, in this particular video we'll be discussing the problem A of Hello 2023. This is a Codeforces contest that is being held on 3rd of January 2023 itself. So the problem A states that Thalia is a legendary grandmaster in chess and she has n trophies in a line numbered from 1 to n from left to right and a lamp standing next to each one of them, and the lamps are numbered as the trophies themselves. A lamp can be directed either to the left or to the right and it illuminates all the trophies in that particular direction, but not the one it is next to. More formally, Thalia has a string S consisting only of characters L and R which represent the direction of the lamp, and the lamp I illuminates trophies 1 to I minus 1 if the direction of the lamp is left and it is represented by L, or they can illuminate I plus 1 to n trophies if the direction of the lamp is right, that is marked by R. Also they have given also we can perform at most one operation, so we can choose an index I and an index I plus 1 and we can swap the lamps on those two locations. Now what they have given us the constraints. So the overall constraint is that the sum of n, that is the length of the string, the sum of the length of the string in the entire test cases won't exceed 10 to power 5. They have asked us to print -1 if it's impossible to illuminate all the trophies even by performing operation. Else we can print 0 if all the trophies are already illuminated even before performing any operation. But if we are performing an operation to illuminate those lamps, then we have to return the index I if we are swapping the indexes I and I plus 1. So with that, let's get started. So what they're saying is that let's say this is a string and we have trophies over here. So let's say these are 4 trophies I'm having, and then there are lamps. So every trophy would have a lamp behind it, in front of it, however like whatever you want to consider, and they'll be having letters on top of it. So this lamp would enlighten everything or illuminate everything to the left of it, but it has nothing to the left of it, so it won't be able to illuminate anything. This lamp would illuminate everything to the left of it. On the left of it there's one trophy, so this would get illuminated. This particular lamp can illuminate everything to the right of it, so this would illuminate this particular trophy. This lamp can illuminate everything to the right of it, but it doesn't have anything to the right, so it can't illuminate anything. At the end we can see that two of the trophies were illuminated, however 2 weren't. Also a simple observation over here is as soon as we get a R, so everything to the left to the right of it is already illuminated, so we need not check this particular part of it, because we can safely assume that everything is already illuminated, so we need not check this part. Also as soon as we get a L, we can assume that everything to the left of it is already illuminated. So in case we get a scenario where there's a R and then there's a L, so this would mean that R was able to illuminate everything to the right of it and L was able to illuminate everything to the left of it. In totality it would illuminate all the trophies. So if this is the case, we can simply return 0, because even without performing any operation we are able to illuminate everything. Now let's talk about another case. What if the string contains all L's? So this would mean that this particular lamp is able to illuminate everything to the left of it, right? So we need not check anything for these, but the trophy just on its head won't be illuminated. So there's still one trophy that's not illuminated and there's no way you can illuminate it. What if they're all R's? If they're all R's, then the first R itself would be able to illuminate everything to the right of it. However, the trophy on the head of it won't be illuminated. So in both of these scenarios, we won't be able to illuminate it and we'll return -1. Now, what if we covered 2 scenarios. So one scenario is that we have anything like this. So X can be either R or L, whatever. And then we have something like a R and a L. So as soon as we get it, so we can say that R covers this and L covers this. In totality, we cover everything. So we'll return 0. If it's all else, so we'll have to return -1, because we can't illuminate every lamp. If it's all R's, then we'll also have to return -1. What if it's a sequence like L L L L and R R R? So a number of L's followed by a number of R's, where L could be anything greater than 1 and so could be anything greater than or equal to 1 and so could be R. So in this particular scenario, these two lamps won't be enlightened. or illuminated. The trophies in front of these two lamps won't be illuminated. So what we can do is we can swap these two particular lamps, and then all the trophies would get illuminated. So in this particular scenario, we'll have to return the index of this lamp, and that's what we are going to do in the code itself. So let's see the code. So in the code, you can see that firstly I'm checking whether I have a right lamp and a left lamp, because if there's absence of these kind of lamps, so let's say if I have all R's and L is absent, or all L's so R is absent, then I'll have to return a -1, right? So that's why I'm checking this. Then I'm checking if there's a presence of the pattern RL as we discussed. If there's a presence of RL in the string, then I can simply return 0, because all the lamps would already being illuminated. Then I'm checking that if there's not a presence of RL, then I need to check a index at which there's a L followed by a R. Now as soon as I find this particular index, I can return I can return that particular index, and this was a AC solution. So if I check the code, so you can see it was a AC solution. I'll put the link to this particular code in the comment section itself. You can check it from there. Thanks a lot, guys. Let me know if you have any questions. I'll be more than happy to answer them.